You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that had, has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and share it with friends. Thank you. This is Richard Jacobs with the Future Tech and Future Tech Health Podcast. I have a returning guest, Gregory Kuehn. He's with Prescient Metabiomics. They're doing some sort of partnership or merger, and they're going to be called Prescient Metabiomics, not just Metabiomics. So, Greg, thanks for coming back. How you doing?
Very good. Yes, it's a joint venture that we forged with Prescient Medicine, and that's where we became Prescient Metabiomics.
And you can say that was very prescient of you to do so, right?
Absolutely.
Well, for listeners that haven't heard before, tell me about Prescient Metabiomics or Metabiomics. What do you guys do?
Well, Prescient Metabiomics is a pioneer in the development of human microbiome and metagenomic technology. We've been, for the last 15 years, developing the technology platform to do, advanced interrogation of the gut microbiome and associating the microbiome with health and disease.
Okay. So are there specific conditions that you're targeting, or, health and disease, how is that defined according to you guys?
Well, that's an interesting point, actually. So we are, the technology actually represents a new paradigm for looking at human health. We can analyze the microbiome and actually through clinical trials associate the changes in the gut microbial ecosystem with various diseases and conditions. Our company very early on developed a focus for gut health, and so inflammatory bowel disease was an initial focus for the company, and that eventually led to the discovery that we could actually predict colorectal adenomas, which presents the opportunity for preventing colon cancer. And that's largely what our company is focused on now, is developing a screening test for precancerous adenomas and carcinomas with the goal of trying to prevent colon cancer.
Okay. And so what have you seen? How is the microbiome apparently correlated to health or disease? All I hear is, more diverse microbiomes are correlated with better health outcomes. But beyond that, I don't get any details. What have you guys figured out?
Well, we've, as a company, dug in a lot deeper. And we're modeling specifically, a situation where there's colorectal adenomas or colorectal cancers versus healthy. And we define healthy with a colonoscopy. And further, we're digging into the etiology of the disease. So the microbiome doesn't just help digest food, and there's actually a very complex relationship going on. So the microbiome activates and regulates the immune system. The microbiome is the first line of defense, fighting off pathogenic bacteria. And a disruption of the microbiome is kind of what we've developed it into a biomarker for these diseases, because it's kind of related to signs of chronic inflammation or perhaps genotoxins being developed by the microbiome. we're trying to dig into the functional relationship between the gut microbiomes, the gut microbes, and the human host.
So, like an example, C. difficile. It appears to come out in people that have had antibiotics multiple times, et cetera. But from what I know, it exists in the gut normally, just in low levels. But in a dysbiosis situation, now it's predominant. So that means like it was always there. Was it really a pathogen, or not until it just reached a stage where it's predominant and now it's causing problems? Like, how do you evaluate what, again, a healthy microbiome is versus a dysbiosis? Is it by prevalence? Is it by appearance or not appearance of a certain organism? Is it by other factors?
That's a good point. So there's essentially there's a gut homeostasis that is trying to define gut health, and that essentially is a stable configuration of the gut. And there's various ways in which dysbiosis can occur. And that's a dysregulated immune response, a defect in the epithelial barrier, or a extreme overgrowth of certain pathogenic bacteria, or even some bacterial strains that were formerly symbiotic that become pathogenic to a certain extent when they're sort of getting out of whack with the host.
Okay. So in particular with the cancers that you're looking at, what have you seen? Have you seen, have you looked at the cancer cells themselves, and do they interact with the local microbiome differently? Do they attract a hyper-specific like microenvironment of microbes that are unique to them? Like, what have you seen there?
Well, there's been an absolute explosion in the field. And so many researchers all around the world digging into these questions. And so we've focused on actually most recently taking a lot of those studies, and we're looking at it from a 30,000 foot view. So part of this revolution is also AI and machine learning technologies that we're deploying. So we're looking at actually, hundreds, if not thousands of biomarkers, and developing approaches to actually tease the signal from the noise. So exactly those questions. So what biomarkers are important? What aspects of the functionality of the microbiome are important, and how can we zero in actually to use that knowledge to incorporate it into our predictive models and diagnostics algorithms ultimately.
Is a metabolite the same as a biomarker to you, or are they two different things?
A biomarker can be anything. It can be, a gene, a protein, a metabolite, et cetera. We're focusing primarily on metagenomics, metatranscriptomics, essentially. But really, there's also a lot of work that's been going into the metabolome. So looking at the metabolites, and additionally, digging into the omics a little bit further. So viruses and fungi. So there's actually not just bacteria that are in play, but also more recently there's been the discovery that even the viruses and the fungi may play a role in carcinogenesis.
So what kind of specifics have you found? I mean, I know there's certain things you can say and some things you can't say, but within the realm of what you can say, what kind of specifics can you point out that you've discovered?
Well, like I said, we are developing. We're focused primarily on actually the predictive model. So it's actually the 30,000 foot view, and so it's a combination of hundreds of different markers and comparing those hundreds of different markers between the disease state and the healthy state all at once. So the actual specific findings related to the etiology are something that essentially is to be explored later. Actually, sort of, you can drill down or initiate kind of a one-off study to look at any particular mechanism of action. We're essentially, using machine learning to model all of it at once.
Okay. How successful has the modeling been? Like, again, what jumps out at you? What have you seen so far?
Well, what jumps out really is the incredible opportunity. So, because it turns out that this system, this microbial ecosystem that we're able to measure now for the first time, is very sensitive to a situation of colorectal adenomas and carcinomas. So we have, we're developing a test that may be more accurate than any other existing test for predicting the presence of a colorectal adenoma, for example. And that's incredibly important because essentially the colon cancer screening programs in the United States and around the world are all designed to try to detect adenomas in the interest of trying to prevent cancer. That's essentially why you go and get a colonoscopy as recommended. Colonoscopy aims to detect adenomas, and most often when adenomas are found, they're removed via a polypectomy. And that polypectomy actually is what has been demonstrated to prevent cancer. And so the problem, however, is that previous non-invasive diagnostic approaches weren't sensitive to colorectal adenomas, and so therefore that led the screening programs to rely so heavily on colonoscopy. But because colonoscopy is so expensive and invasive, and there's a limit in terms of the geographic locations of endoscopy centers, that's sort of why colon cancer has persisted as being one of the highest cancer killers, actually number 2. And so what the system really needs is actually a non-invasive test that is sensitive to adenomas, and that's what this technology is hoping to deliver. And really, what it is so we're kind of assessing the overall gut health from the perspective of the microbial ecology, and that's what the paradigm shift. So, and so that's sort of an indicator of disease, and it's enabling us to now select patients that are at high risk for having adenomas or carcinomas, and then we can actually advise those patients to go into a colonoscopy at that point and sort of get more people into screening programs and ultimately find more colon polyps and adenomas and carcinomas. And the opportunity is actually to completely eliminate colon cancer. That's how large of an opportunity it is with finding these adenomas.
Where does, the colon's pretty big. The large intestine goes, all around the stomach and down. Where does it happen typically, like in the sigmoid colon or in the rectum? And when you're looking at bacteria, I would guess the only accessible place is like the proximal colon, right? The rectum and the sigmoid colon, like the rest of there's a lot more colon in there. I don't know if anyone knows what's going on in there because it's kind of, buried.
That's true. Most colon cancers all develop in the lower intestines, and actually one hypothesis is that that's where all the microbes are. But there's also an incredible amount of other activity going on there, and that's essentially what is triggering carcinogenesis is a variety of factors. Including chronic inflammation, potentially, genotoxins that are produced by bacteria, and other factors that sort of are, they're feedback mechanisms that essentially are causing the damage to the genomic DNA that actually triggers the cancer. And the most common pathway is of carcinoma progression is that is sort of well understood is that a slow progressing adenoma, so polyp to adenoma to advanced adenoma to carcinoma, that's traditionally been understood to be around about a 10-year process. However, in the last 5-10 years, with the explosion of all these omics technologies, we've actually seen that there's perhaps as much as 40% of cancers actually start from non-advanced adenomas. So very small polyps that are sort of that sort of jump straight into cancer, and that has been why there's been more been more interval cancer, so cancers that pop up in between the screening intervals of which is recommended every 10 years colonoscopy. But if you have small adenomas that are essentially jumping straight into cancer, which is a different pathway into carcinogenesis, and that's sort of why we may have an advantage as a screening test strategy, because we're picking up on actually the earlier signs of non-advanced adenomas, in addition to the advanced adenomas and carcinomas. So it's sort of with the power of the omics technologies, we have a potentially new way of stratifying risk for colon cancer that is going to be a valuable new tool for screening programs.
So again, what have you seen changes? If someone has no adenomas, what does their microbiome look like in the colon versus adenomas versus carcinomas versus whatever stage is next, if there is a next stage?
Well, like I said, it's hard to pin things on a specific culprit, and that essentially is why it's been a tricky problem. So it's not as if there are a few bacterial species that are the culprits. It's actually a system that's so complex. As I mentioned, all these different factors. That it's sort of like looking at the health of a rainforest and actually trying to like understand whether the rainforest is healthy or not. If you look at a few species, and you might and they're in the genes actually that are present in those species is kind of the view that we're looking at, and trying to extrapolate that to whether the rainforest is healthy or not. That's how complex the system is. And fortunately, I think that in the situation of colon cancer or inflammatory bowel disease, or a situation with colon polyps, you have some significant problems that are, the signal becomes loud enough actually that you can isolate it with the AI and machine learning approaches. And I think that it ends up looking something like, part of the forest is burned down. I mean, so it's a significant problem with the ecosystem.
Any idea of, I don't know if this factors in, but how often the person that you're, sampling, or the creature that you're sampling goes to the bathroom? You're like, I know this is really getting into like literally gross detail, but some people, they may go to the bathroom like twice a day. They may have a bowel movement. Some people may be like once a day, once every other day, once every 3 days, God forbid, longer. I don't know. I would think that might have a huge transformative effect on their microbiome. Like even when someone's bowel is empty, what does it look like in this, in the proximal colon versus as it gets filled up with matter? And then when it's full, what does it look like? And then right after evacuation, what does it look like? I wonder if the microbiome, because of the stuff that's in there, like radically changes locally and then changes again as it gets full and empties.
You're absolutely right. There is many different components that you could look at. So there are daily changes in the microbiome, and of course changes with food. And about 50% of the genetic material in a bowel movement is microbial, and most of the rest of it is from your food. There is actually a stable component of the microbiome that's able to be modeled over time, and it's actually been observed. You can see the microbiome recovering to a stable state following disruptions such as a course of antibiotics or a colonoscopy or some sort of shock such as that. And but also there's in order to characterize the a healthy from a disease state, we're also doing signal processing and teasing the signal from the noise. So essentially the microbes that change every day to a certain extent kind of fall out of the model because they aren't predictive of the disease state. And so that's sort of what I can say about that.
Okay. What do you expect?
I guess to add a little bit more, the stable component of the microbiome, is related to, biofilm production, or kind of the more there's pockets that are in the epithelium, the mucosa, that where these microbes are preserved, and essentially they shed out into the lumen, and that's sort of what we're measuring.
Okay. What do you think are going to be some of the breakthroughs that you're going to come up with in the next, year or two, or is it going to be much longer term than that?
Well, yeah, we are unique as a microbiome diagnostics company in that we are pursuing FDA clearance, and so that's actually the biggest news of the company is that we've received a breakthrough designation from the FDA. And that gives us access to the Breakthrough Devices Program, which accelerates our path to market. So we're working now on with experts at the FDA to put together a clinical validation plan, and we're ultimately going to be doing a clinical trial with thousands of patients, and so that's sort of something that's new, a new frontier for microbiome testing is getting up to that level of clinical validation. So having thousands of patients that receive colonoscopy as the clinical truth, and the histopathology. So having that as a positive versus negative for predictive modeling is very powerful for actually untangling the complexity of the gut microbiome and its impact on health.
Okay. Well, very good. What's the best way for people to find out more about Prescient Metabiomics?
We have two websites I can point people to. One is metagenomics.com, and another one we just launched is powerofprediction.com, which is a website in partnership with our strategic partner Prescient Medicine.
Okay, so best thing is to go to metabiome.com, or is there another resource?
Metagenomics.com.
Metagenomics.com. Okay, that's the best way. Okay, well, very good. Well, Greg, I appreciate you coming back, and thank you.
Okay, thanks a lot.
You're listening to the Future Tech Health Podcast with Richard Jacobs. Until I reached age 40, I never realized the obvious, that we all have medical issues, or we at least have a family member or close relation that has, or will have them in the future. Medicine and biological systems are the final frontier. Until we've conquered death, figured out how life began, cured cancer, and understood our purpose in the universe, there's a heck of a lot to talk about when it comes to our health. Future Tech Health means I'll be covering futuristic topics that are actually already in clinical trials, or even starting to appear on shelves or by prescription, or available for your own use. We dive deep into stem cells, CRISPR-Cas9, the science of sleep, epigenetics, medical testing, cancer, ketogenic diets, stem cells, aging, regenerative medicine, and more. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a serious medical problem. Remember, however, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoy the podcast, please listen, subscribe, like, and share it with friends. Thank you.